Well, now they're putting geometry in with our radicals. Find the length of x, they say. Okay, first let's get the geometry clutter dealt with. I'm going to make something that's kind of like this question, only with simpler values just to get a handle on what's going on. If they told you that this edge of the big block was 8 feet, and then they told you that this edge over here was 5 feet, how much would x have to be? The idea is if this thing is 8 feet high on this side, then these two sections separately have to add up to 8 feet as well. Therefore, x plus 5 has to be 8. Therefore, you probably got it long before this, x would have to be 3. The way you get that x is you do the big measurement, in this case 8, minus the smaller measurement, in this case 5, and that tells you how much this extra piece has to be here. Now, we have to do that again, only we have to do it with these slightly miserable numbers they've given us in the question. So our x is going to be this measurement for the left edge minus this measurement for part of the right edge. That means 8 root 2 plus 2 root 12 minus 5 root 27 minus 4 root 18. So, the brackets are not nice. Let's get rid of those first. 8 root 2 plus 2 root 12. Minus applies to this, so you get minus 5 root 27. Then minus also applies to this, so you get plus 4 root 18. Now, these roots cannot be added or subtracted the way they are now. We have root 2, or root 12, or root 27, and root 18. Useless. But you remember, we can try to reduce these, and when we've reduced them, hopefully they will look better. So, root 12, I want to take a perfect square out of it, like so. 27, that has a 9 in it. And 18 also has a 9 in it. So, now if we clean this up, 8 root 2 is already as nice as it's going to get. 2 times, that's also 2, so we get 4 root 3. Right, that's the square root of 4 is 2 times the 2 we had already makes 4. Square root of 9 is 3 times 5 is 15. Root 3. And finally, the square root of 9 is 3 times 4 makes 12. And then we have root 2. So, now we have some things we can add. We have 8 root 2's, and then 12 more root 2's, for a grand total of 20 root 2's. Then we have 4 root 3's, and then we lose 15 root 3's, so we're now down 11 root 3's. That is the exact value. If you put that into a calculator, and calculator can compute these, times 20 minus 11 times the square root of 3, I get 9 point, oh, they went to the nearest tenth, so I get 9.2.